go ahead and turn in assignment number 3. So what you have is assignment number 4, and it's due on 28 according to our schedule. Let me check one more time. Let's see. 26. It's due 26. Okay. So, so as long as you finished the lecture today, actually you already know how to do number 1 because last time we talked about cost function revenue and profit function already. So you should be able to do number 1 at this moment. Okay. Number 2, after the lecture today, you should be able to do that also. For number 5. Number 3 should be, we talk about the concept that used for number 3 next on Wednesday this week. And number 4, hopefully we have enough time to cover concept for number 4 today. Okay, number 4 is pretty simple. It's not really that bad. Okay. Any question? Oh, let me see. I believe that I still have some. Let's see. Yeah, you haven't studied the physical assignment. You can get it. But for number 2, I haven't graded it yet.
Okay, that's fine.
I haven't graded it yet.
Told me to stop.
Yeah. Okay, you have to give me. Yeah, so I haven't graded it yet. So it's still here.
That's okay.
So you gotta give me the work. Okay.
Oh, I need it.
Yeah, oh, you sent me the PDF file, right?
Mm-hmm.
Yeah, you gotta give me the work. I have to write the work. So I haven't.
Wait, what?
You gotta give me the work, the physical work, not the electronic one, not PDF file. I don't receive the PDF file.
Why?
Oh, don't take it. I don't take PDF file.
You want me to?
So just rewrite it. Yeah.
Okay.
Yeah. Just rewrite it. All right, Jenny Gate. Who Jenny Gate here? Okay, our daughter. This guy never show up. You guys don't show up. I got no mercy. Jenny Gate now here, Sarah O'Donnell. Cian O'Donnell's not here. Okay, your first assignment. Okay. Your test. Good. Good job. Okay. Test number 1. Bryson not here. Check it again. Julia. So, for those who didn't do well on the first test, I mean, it's just the first test. Don't panic. Okay? You still have like 3 more chances to show me that you want to learn. So if you screw up the first test, okay, try doing the second one. Try the next one. Okay? Then we see about it. Okay, so don't panic, okay? Everything will be alright. Okay, Andrea. Nope. Okay. Anyone who has not received the test. So if you Preston, I haven't graded your assignment yet. Yeah. You see that on the test, sometimes I put a comment and say that you guys should recheck your learning behavior. Okay, and I want you guys to go to class more often. Go to the math center, get together. Okay, and that's the only way to get better in this course. Of course, you have to do assignment because some of the students, they haven't done any assignment. And it looks like that you've been losing how many percent? 14% already. Oh no, like 6% already. So if you miss two assignments, 6% gone. Think about it. Because 20% for 8 assignments, so each assignment account for 3%. Try to do assignment, okay? Try to do assignment. Even though that you get a bonus, that's fine, but I know that you want to do the assignment. And I know that you go to the math center and you try to get help from them. But if you don't do anything, I don't know. I don't know, okay? So yes, if you screw up your first test, reconsider your learning and try to make it up on the second one and the third one and the final, okay? And everything will be alright. You guys come to class, I see your face. If you guys don't come to class, I don't know you. I don't know you, then no, I don't know what grade should I give you, I don't know. I just give you like probably F. Okay, so you go to class, here you go, I know you probably get a C or D, who knows? I mean, yes, so try to come to class. You pay for the tuition, you should come to class. Okay? And check the attendance, and I see that some students don't even come to class. I mean, that's kind of strange to me. But yes, and all the extra credit, if I give you extra credit, I give everyone extra credit, but not a lot of students do extra credit. I know it's worth only 2 points, but it's worth it, guys. It's not because it's 2 points, it's because you do the extra credit. I know that you want to be better. When I know that you want to be better, there you go. Maybe I'm kind of lenient on your final grade. Okay? And there's no policy of curving. No curve. But I could be lenient. Okay? I already told you at the beginning of the semester, I said you got like 65%, but you showed me that you did a lot of homework and you do all the extra credit. Oh no, maybe I'll give you a passing grade. I give you a C. But if you don't do anything, you got 65%, it means the 65%. You stay there. Alright, so try to show me something, okay? Get better, and don't panic, guys. Everything will be alright. It's just the first test, okay? We've been doing warm up, okay? We're going to try better on the second test. And I haven't said the second test is harder, yes. And the third test is very hard. You guys check the assignment, you see that the assignment kind of getting harder, right? It's getting harder and harder. And sometimes even the tutor is very hard. It's hard for them to get it. But it's not hard because they couldn't see that either. So on the solution of the test, I will send you the PDF file, the solution, and I send it through Canvas message. So hopefully I can send it tonight. The solution of the assignment, I try to upload that also, the video, and watch it. Not a lot of students watch it. So please watch it. Of course you don't have to subscribe, I don't care about that. But the reason I do the video is just because it's easier for me, I can just go ahead and write them down and make a copy. It's even easier. But the video, when I try to correct the problem, when I try to show you that, okay, I want you guys really understand the problem. It's not just because of the solution, the answer, no. If I just give you the solution and I give you the PDF file, that's all. But I make the video, and it took me a lot of time. Like for each assignment, 45 minutes. Yes?
Where can I find these videos?
Oh, the video, I sent you the link already, right? So order the link there, and there's the channel. Okay. Let me see. Hopefully we have time. All the video is in that channel. Let me see, I can find it here. So the solution of the first test, I don't have enough time to upload the video. So I'm going to send you guys the PDF file, but hopefully on the second test and the third test, I will send you the video. Or maybe, who knows, later on I may have time and I post the video. And then the second test and the third test, I give you the PDF file. Let me see, I can connect this power on. Any questions? Yes.
Are you gonna put our grades in at all?
Oh yes, of course. Yeah, right now, I'm not going to do it. I will tonight. Yes.
So we'll see it on Canvas?
Oh no, on Connect Math. So you check your average grade, the percentage on Connect Math. Okay, the percentage will tell you what grade you have.
There's also like a grade book on there.
Yeah, that's a grade book. Yes.
Oh, that's I think the
Assignment?
Yeah, that would be the assignment.
Oh.
Oh, the percentage that it shows right now.
Which is
Well,
for
right now, yeah, except for the science.
Yes, there's a grade book on the Connect Math guy. If you want to check your grade, go to Connect Math.
You put the test in though?
Not yes, the grade of the test I haven't put it in yet. The assignment I have put it out. I try to do it tonight, okay? So let me see. Connect this to my PC here. Okay, so if you want to watch the video, the solution of the test, you go to YouTube. Okay, and you just need to type, yes, thank you, Orlando Math Learning Academy. Alright, Orlando Math Learning Academy. So I have the solution of the college algebra class I taught last semester also. So this is, you see that this is the lecture number 6 we have here. So this is last week right here. So so this is so let me see. So if you click on Orlando Math Learning Academy, it should give you this right away. So this is the logo I created myself. No one has it. No one. Okay. So if you go here and you see that there's a let's see, I can find a solution of oh, this is my wedding. If you have time, you can watch it. I just married just how many months ago? Like just 6 months.
Congrats.
Yeah, around 6 to 8 years. So right here, so this is last week, right? This is lecture number 6 last week. This is where the assignment. Because I have only one account, so I mean, I don't know where I should post the video, so I just post it here. Okay, so right here, this is the solution of assignment number 1. Okay, because there's something wrong with my microphone, so there's kind of buzzing noise in the back, but it's not really that bad. Okay, so that's the solution, assignment number 2 right there. So you can watch it and learn from it. Okay, so all you see that's why I have a camera. Right? If you miss the class, you can watch the lecture again. Okay, like one day, 2 days after the class, then I post the video, and you miss, then you can watch it again. And yeah, you should watch it. It's not mandatory, but you should. Okay? You don't have to call someone and call your classmate. You have any notes? No, you don't have to do that. So this, I offer you like a lot of things, you know, not a lot of instructor do that, because I'm not, it's not my my responsibility of doing this, no. Okay. I don't have to do this. Okay, so yes, so just go ahead and type Orlando Math Learning Academy and whatever, you see my logo, this is my channel, and you see that all. Okay, order. Okay. Good? Alright. Any questions? Good. Alright, let's get started with our lecture today. So what we've been talking about? Anyone remember what we've been talking about?
Types of functions and how to shift them in the graph.
Okay, we're talking about shifting, right? And I remember last time we talked about shrinking and stretching horizontally. Is that correct? Okay. Let's see, let's cover that. Let's finish that and we're going to jump to the new thing. Let's see where we at. Textbook here. Okay, so let's continue with that. So we talk about shrinking and stretching. Okay, horizontally. Okay. This is one type of transformation. Okay, and let me give you the example. Actually, last time I gave you the graph, you know, the upside down V shape. You can use that as an example. I'm going to go through that really quick. But let's start with the whole thing. Let's talk about the absolute function. I'm going to use this as my example. And anyone remember what is the function of absolute function? F of x equals what?
Yeah, f of x equals the absolute value of x.
Absolute by x. Okay. Okay. That is our parent function, and this function has domain from negative infinity to positive infinity, and the range from 0 to positive infinity. Okay. Of course, including 0. Okay. And I want to compress or shrinking. I want to compress or to shrink this function, this V shape, horizontally. Just imagine, okay, I have V shape like this and I compress them horizontally. So my new function will become like this, right? That's my new function. And my new function is f prime x equal to a absolute. A is x, everything inside the absolute. Okay. And with a, it's greater than 1. Okay, this is a greater than 1. For example, I have absolute of 2x, absolute of 3x, absolute of 4, 5x, as long as it's greater than 1. Okay? So they become thinner. They become thinner compared to the parent function. Now, instead of compressing horizontally, now I want to stretch them out. Just imagine I pull 2 branches of this function, I pull it away, okay? And my new function, the graph of my new function will be something like this. And this new function is f prime of x equal to also absolute of a of x, ax, but a right now at this time, this one will be between 0 and 1. Between 0 and 1. And the only difference between shrinking and stretching horizontally compared to the shrinking and stretching vertically, because we stretch and we compress by the factor of 1 over a. It's not by the factor of a anymore. Last time we compressed and we stretch by the factor of a. This is we compress and shrink by the factor of 1 over a. Okay? So from this graph, I can generate the formula. So the new function f prime of x will be equal to f of a of x. So you see that my factor a, my coefficient a, or you can say my constant a, it become a part of the input. It's become a part of the argument. It's different from shrinking and stretching vertically when a is in front of the fx. you compare the formula. Last time your A is over here. Yes.
Wouldn't wouldn't the rules that you wrote for A be absolute value? Like absolute value is 1 and 0, and A is greater than absolute value of 1.
Oh, we have 0. Like this is between.
Or absolute value of A, my bad.
You
Because,
have absolute of A only.
well, if you put a negative number in there, it's...
So if you have a negative number, absolute becomes positive.
Yeah.
So we don't have positive. We don't have negative case here.
Yeah, but you can still have a negative A there.
You have negative. Yeah, but I mean, if it is negative, you take absolute become positive.
Yep.
And so it doesn't matter anymore, right? It still go back to the one of these two cases.
Okay.
Yeah, because if, for example, if you say it's negative 3x, right?
Mm-hmm.
Absolute of negative 3x is just 3x. So 3x is in this case now because a is greater than 1. So your a at that time will be 3.
Right.
Yeah, it will be greater than 1. So I'm going to consider it's going to become thinner. The graph becomes thinner compared to the parent function.
Yeah, because you're just changing the slope, right?
Yeah, I just change the slope. Yeah. Okay. All right. All right. So you see that your a over here is become a part of the input. It's not. It's not in front of the function fx anymore, but it's inside the function. It's become an argument of the function. Okay. All right. So my a, if a is greater than 1, I know that we shrinking horizontally by a factor of 1 over a. Okay, by a factor of 1 over a. And if a is between 0 and 1, it will be stretching horizontally by a factor of 1 over a. So I feel like if you look at the graph, look at the picture over here, I can say that shrinking horizontally is kind of the same as stretching vertically. Because if you stretch vertically, you're shrinking horizontally, kind of the same. But the coordinate will not, it's not the same. The coordinate will be different because the coordinate depends on the factor. For vertically, we stretch or shrink by the factor of a. But for horizontal stretch and shrink, we stretch and shrink by the factor of 1 over a. It's different. Okay? Alright, let's take a little look at an example. I believe that last time I gave you a function, and the function it looked like something like this, right? I believe so.
Yeah.
Yes. Okay. Something like that. Okay. And let me see. And I want you to graph the function f of x equal to f of 2. So this is function f of x. This is function f of x. Okay. Now I'm going to graph function f of 2 of x. And you see that right now my a is 2. Okay, my a is 2, and number 2 is become an input, it becomes the argument, because it's covered by the parentheses. Okay? And know that because a is 2, a is greater than 1. So in this case, a is 2. It's greater than 1. And because it's greater than 1, so my graph of the transform function, the transformation will be thinner. But how much is thinner? Okay, how much thinner? Let's say this coordinate here. I believe that I also give you the coordinate here is 3, 3, right? I believe so.